All right, everybody. Good morning or good afternoon, as the case may be. It is 11:01 a.m. by my watch in Chicago, so it's time to begin. Thank you for attending this PowerCast, 5 SQL Tips Everybody Should Know by Birgitta Hauser and Steven Spieler. This PowerCast is sponsored by HelpSystems. My name is Ian Cartwright, and I'm Education Manager for Common, and I appear on your screen as webcast host. If you experience any technical issues during the presentation, go ahead and send me a chat message using the dialog box, which is on the right frame of the screen. If you'd like to send a written question to Birgitta and Steven about the content of the presentation, for that, you're going to use the Q&A area, also in the right frame of the screen, and select to send to all panelists. Steve and Birgitta will answer your questions at the end of the presentation as time permits. As I said, our presenters today are Birgitta and Steven. Steven, you're in control. Go ahead.
Well, hi, everybody. I'm Steve Spieler. I'm a training and services consultant at HelpSystems. And just to tell you a little bit about myself, in 1998, I began assisting organizations with IBM mid-range systems in meeting their information needs. You may recall that as the birth year of the AS400. Now, in 2002, I began working with SQL, which is what I do primarily now. I'm pleased to be part of today's presentation, and I'm going to pass it over to Birgitta because she'd like to tell you a little about herself. Go ahead, Birgitta.
Okay, hello. First, some greetings from Germany, here in the south of Germany near Munich. And my name is Birgitta Hauser. I'm a traditional RPG programmer. I started programming in 1992, but since the beginning, since I started programming, I always used embedded SQL. And SQL and database is still my favorite today. Today, I'm working less in programming, but more in application modernization, in education, and in consulting on the IBM I. And my favorite or my main focus is on RPG and the database. Sometimes I'm writing for a German publisher or sometimes for IBM. And I already helped writing red books, but long ago. And now, Steve, please continue.
Thanks, Birgitta. Well, as you can see, HelpSystems is on the screen because we're presenting this webinar for you today. Now, we at HelpSystems are on a continuing journey to help organizations everywhere build a better IT. Our offerings include many areas that affect you, and as you can see from the screen, but today we're really focused on business intelligence. So let's take a look at today's agenda. It begins with Birgitta, who's going to present to you her first two great SQL tips. Now, once she's covered those, I'm going to present you with some ways that SQL can be enhanced and extended with SQL from HelpSystems. After that, 3 more SQL tips will be presented by Birgitta, after which we'll do a Q&A and wrap up. So with that, we're going to pass control over to Birgitta so she can begin her first 2 tips.
So my first tip is like predicate. So I assume almost everybody had heard about the like predicate or had used it. When we use a like predicate, we can use 2 placeholders. One placeholder is a person sign, which means an undefined number of characters. So for example, if we specify in the composition with a like predicate, here the first one, XXX%, it means the string must start with XXX and the rest doesn't matter. The other thing is here we have the person sign at the beginning. That means the last 3 characters need to be XXX, but be careful. You may have fixed length column. And if you have fixed length column, you may have blanks at the end. So you first have to remove your blanks, and then you can compare it or you can search for the last characters. And if you put the person sign on both sides, it means somewhere in our text needs to be an XXX. That's what almost everybody knows. But we have a second placeholder, which is an underscore. Underscore means exactly a single character. We also can have multiple underscores in a line. And for example, here we have underscore ABC. That means the first character doesn't matter. But then we search for ABC and then the rest doesn't matter. For example, if the 4th character starts with ABC, then we can have 3 subsequent underscores. That's possible. We can have it at the beginning, at the end, in the middle of the string. Doesn't matter where it is. It means only a single character. Here, the next one means undefined number of characters. Then we must have ABC, and the last character doesn't matter. Again, we have to be careful here with our fixed length character fields. Let's have a look at our fields at my presentation. So let me share my screen here. Let's go on this one. And I assume you see, I should have started at the beginning. So here we have a few examples. I have a small address table, which is here address X. I hope I did not lose my connection. No, I didn't. So and here you see, for example, here we have a lot of names with GmbH. GmbH is a German and stands for incorporate. So and here you see it, we have GmbH, and we search for everything that has a GmbH. So I just put it here in the where condition, customer name like GmbH, and here they are. But not sure if you have seen it before. Here we only have these GmbHs that are written with a uppercase G and uppercase H and lowercase GmbH. If we go back to the slide, we see here, for example, we have GmbH in lowercase characters. Here we have it everything in uppercase characters. If we need only all GmbHs, we can do it very easily. We just use another function, not another function, we use a scalar function. We can use either upper or lower. Upper converts everything into uppercase. And now we compare here the string in uppercase and search in our uppercase string for GmbH. So here it is, and now we see it. I sorted it by the customer number. So we see here GmbH, and here is everything in the uppercase notation, and here is it in the lowercase notation. So we have everything. By the way, if we talk about this function, here I ordered it after the customer number. If I sort it after the customer name, so here again, we see the following. Eugen Fischer is everything in lowercase. It's at the beginning. Then we have Arborg, and Cyber is, for example, before ComCon, because it's independent, it's case sensitive. But we also can use this function upper in the order by conditions, even without specifying it in the select list. And if I put it here, now we see, okay, now it starts with Arborg, ComCon, CSP, Cyber, and here is our Eugen Fischer just in the middle. Just as an aside, we can use it. Now let's have a closer look at something else. For example, here we see a name Schmidt. Schmidt is, for example, a very common name in Germany, but we can write it in different ways. So with TT or DT, I'm not sure how he is written, whether it's Schmidt with DT or TT. So I say, okay, I search for Schmi, and then at the end a T, and then between the I and the T must be any character. So search for it. And exactly that's what I do. And here we have it. Here we have Erwin Schmidt with TT and Hans Schmidt with DT. Now that's very easy. And so we can use it. But now we have the next question. Let's have a look here in our address table. And what you can see here, we have several names with a person sign in it. And now we need to select all our customers which have a person sign in their name. How can we do that? That's a little tricky, because a person sign means undefined number of characters. So if we specify it like here, where customer name like person sign, we get a problem because it selects everything. So how can we get names that include a person sign or an underscore. What can we do? And now let me go back to my presentation. If I find it. Sign. And we can use any character as an escape character. Doesn't matter what we decide for. So in this example, I decided for question mark, or here the same thing. So here it means it has to start with a percent sign, XXX, and then must be a percent sign, and then AAA. Or here we search only for a percent sign. But since we can decide what escape character is, or we want to use, we have to specify it. And this is just easy. We just specify after the pattern here escape, and then we specify our percent sign. And there is also another way. If we are looking for whether our string contains a percent sign or an underscore, there are several scalar functions. So we have the poststring function, we have the locate function. They work almost identical, even though locate is more powerful than the poststring because here it has an optional parameter. Let's go back to the presentation or to the demo, and we can then have a look on it. Let me go back to my screen here. Here we are. So the first thing here, I just decided for an exclamation mark here for searching for percent signs. And I search also for my underscores. And this time I use a question mark. I also could use twice an exclamation mark or twice a question mark. I could also use a character or even a hex value would be possible. That's all possible. So I just select it here. And now we can see it. Here we have the percent sign. We have them here, percent signs. Here we have two names with the underscore, and here we have another percent sign. Next question. If we only want to have the text with at least two percent signs, how do we have to change this expression here? Okay, we just have to escape the second percent sign. So if we specify it here, we only get a single one. Why? Because this means two subsequent percent signs. If we want to have everything that has at least two percent signs, so we can change it here. So we have here an additional percent sign. And so we get everything that includes two or more percents in the text. I said here's an example, for example, where we use the locate. But with the locate, locate works like the scan in RPG. That means it returns the position where it finds the percent sign or the underscore in this case. And if this position is greater than zeros, so we get the result. And here it is. If you are looking for more than a single percent sign, it becomes a little more tricky. So in other way, use the like with the escape sign. Okay, then we have another thing, another tip. Stop sharing. Let's go back to my presentation here. Oops, sorry, it was the wrong one. Here it is. And now go down. We will have a look at the trim. Okay, you say, trim, I know it. Let's have a look whether you really know it. So what everybody knows is we have the L trim, the R trim, and the trim. With these functions, we can remove leading and trailing blanks. I think almost everybody has used it already. So the L trim will remove the leading ones, the R trim, the trailing ones, and the trim will remove them on both sides. Let's go back to the presentation here. Share screen. Go back to the slide. Okay, here we see I have my address table. I search here in my contact everything that has a name in it. And you see here we have leading and trailing blanks in the names. The names are on different positions. If I just write left trim, everything is left adjusted. As you can see it here. If we take the right trim, I have two examples here. I just concatenate my first and concat and customer name. And so you can see both are fixed lengths. And so everything is here on the same position. If I use an R trim here and concat add a blank and then concat the customer name. So it's not left adjusted, but the rest is now concatenated correctly in the way I want to have it. And the last thing is I just use a trim. Trim removes on both sides. So here we get the text. Okay, that's an easy one. That's what almost everybody knows. But now let's have a closer look again. I have here texts. And here my texts start with asterisk and end with asterisk. And they end on different positions. And yeah, we have different number of asterisks. Now the question is, this can sometimes happen. For example, you get something from an interface with a number with leading asterisks, and you have to remove it. So how can we remove that with SQL? And we only want to remove the leading and trailing asterisks, but not these asterisks here in the middle of the text. So how can we do that? That's a little tricky, but it's very easy and it's stone old, because this technique that I want to show you is, I have used it already with release 4.5 long ago, and the trim command, what we know is not the complete syntax of the trim command. Our trim function starts with trim. Then we can specify leading, trailing, or both, or an L, T, or B. Then we can specify a strip character. That can any character, for example, in our situation, the asterisk, and then from is part of the syntax and the expression. And in this way, we can easily remove leading and trailing characters from a string. Let me have a look here. I just take here leading, trim L or leading, and remove it from my name. And so you can see here everything is left adjusted. All the asterisks are removed. Okay, we do the same thing with the trailing ones. Okay, here in the last 4 ones, everything is okay. But what happened here? Why we still have this trailing asterisk here? What's the reason? Look at the first column here. So here we have trailing blanks. If we want to remove this asterisk, what do we have to do? Very easy. We just have to trim off the blanks first, and then we can use it. That's exactly what I did here in the next example. I just nested my trim with the regular trim or the trim, how everybody knows it. And now we see it here. All the trailing blanks, asterisks are removed. And if we take the both, same thing, just trim them. And here we have all leading, trailing asterisks removed. And here we still have the asterisks in our text. By the way, the right and left trim were enhanced in the last few releases. So for example, if we get something like this here, we have trailing leading asterisks, and here at the end we have the currency. We can do it. For example, here I do it in several steps. So here for the left, I take the left trim and I remove the asterisk and the blank. And for the right one, I just remove the following characters and a blank. And if we have a look here, so the right ones are removed and the left ones are removed. Unfortunately, trim is not enhanced, but yeah, we just can nest it here. So I just have here the left trim, remove the leading ones, right trim, remove the characters, and then finally I convert it into a numeric field, and here it is. So let's go back to my presentation, and it is Steve who wants to tell you a few things now. So Steve, it's up to you. Please continue.
Wonderful, thank you. So first off, I'm really looking forward to the next 3 tips, so I can't wait to get through my part to learn a little bit more. But I'm going to talk to you a little bit about how HelpSystems, the SQL product, can enhance and extend your SQL use in your organization. So let's go ahead and take a look. This is going to be very visual. So SQL is great, and it may be everything you need, but really is it? With SQL, you can basically use SQL as SQL as a foundation to what you do, but achieve a lot more based on the SQL knowledge and experience you've got. So with SQL, that kind of blah house becomes something I'd rather live in, a little bit nicer. So again, that's what we're talking about. We're not downgrading SQL. We're basically saying, what more can we do with it? So first off, who is going to use or benefit from SQL? Who needs it? Now, a lot of this is going to be your inquiry designers, and there's different levels of them. So you might have your inquiry designers that are highly skilled in SQL, or the ones that are maybe more moderately skilled. Some that have very minimal or non-existent SQL skills, and you want to be able to cater to all of them. Additionally, who else needs SQL? Your end users do, because they're the ones who need the data, need the information, and depend on it to do their jobs. So with SQL from HelpSystems, we have environments for doing your inquiry design that really hits all the different levels of SQL skills. Highly skilled users are going to probably use the top left, where we have an SQL tab and we can just type away because we know the syntax and we're really comfortable with it. But that's not going to be everybody, especially if you only use SQL occasionally. So we have another designer available in HelpSystems SQL. This is one we call the View Designer. It's laid out a lot like Microsoft Access. And I'll tell you, I work with a lot of people in training and such that use this, even if they didn't have prior SQL skills, because it's such an intuitive environment. So minimal skills, medium skills, and even high skills might choose to use this one. But that's not the only choice. Then we've got one we call the View Builder. This is more of a guided interface so that your user can be guided step by step. Just click next to be given the next choice of things to do, whether it's choose your tables, pick your columns, do your filtering, add your sorting, and your variables. And we'll talk more about those as we go along. And again, this is good for people with no skills and moderate skills. Let's make it even a little bit easier. This is another design environment called the Template Wizard. This allows you to build new inquiries really based on existing inquiries that you've already created. This allows you to have no SQL skills, just pick as you go. And this template wizard is not only going to be very easy when you pick your columns and control your sorting and filtering, or do dynamic filtering by adding runtime prompts, it also allows you guys that are maybe the more experienced designers to control what those non-skilled people actually have access to, because they're based on what you've given them in an already built inquiry as a starting point. So these are things that allow you to use SQL more fully across your entity. But that's just part of it, not just designing SQL, but doing even more with it. And we do runtime prompting on top of the SQL to make them more flexible for you to run things, and more importantly, end users. So here we have date prompting, very easy for doing date range prompts in the calendar functions, or just typing as you need if you want to just type in the start and end dates. That's just one of the types of runtime prompts available to you. Here's another one. This is a multi-select drop-down list. And this multi-select drop-down list is going to grab data from your system, either via tables that you access or possibly inquiries that you access. And you'll also notice it's got multi-select capability, and we're able to get the descriptive word for choosing, but the code for filtering. So this makes it a lot easier for an end user who maybe knows the customers by name, but not by customer number. In this case, I've got state names instead of state codes. Here's another one. This one is a dependent drop-down list. Sometimes people call this a filter drop-down list. And first, we have a drop-down list where we've picked a product class. The second drop-down list is immediately filtered based on that class decision or choice, and we'll only see some of the products, not all of the products in that drop-down list. So it makes it a lot more easy to use and a lot faster to use. We also have what I call highly parameterized variables. Here we have many parameters to choose, and these parameters can be nullified at runtime so that you can tell it to not filter on, in this case, states. So the state filtering is ignored and brings back the activity for all states. And you can do this for any number of your variables, allowing you to create a single inquiry that serves up many different result sets because of the flexibility of the runtime prompts. Another aspect of SQL from HelpSystems are dashboards. So you can take what you've built to retrieve data using SQL, and now you can deploy them in a dashboard. They're easy, they're impactful, end users like them, and in all actuality, this is actually simple. If you've got basic Windows skills and you know which inquiries you want to present on your dashboard in data form or chart or gauge form, any end user with Windows skills can use it. So any designer can actually give this to an end user without having to go and learn a lot about building dashboards. Drill down applications. This is us taking a few simple inquiries and making them work together to create a true inquiry system with many pathways of choice and being able to do, in this case, customer, pass the customer number to get their orders, pass the order number to get their order details. And it's just a few simple inquiries working together. Now, everything I've been showing you is browser deployed as well. All these output options, the variables that should all work in the browser environment that we have with HelpSystems SQL. Here's that drill down in the browser. Instead of right-clicking to bring up your menus, you have these little arrows. Client tables are another truly end-user tool. This allows you to do a lot of dynamic information analysis, whether it's drill down to detail, data pivoting, data filtering dynamically, add and remove summary levels to be able to get it any way you want. Again, Windows and browser. In addition to the drill down, we've got charting, which is interactive for the user. And we've got export to Excel, both your detailed drill downs as well as your just total client table as a way of passing the data along. Output. Another aspect of working with HelpSystems SQL, whether it's in the browser world or the Windows world, and the fact is a lot of our output can be done right from the 5250 world. But the fact of the matter is not only can we display our results easily as you've seen, but we can save them as PC files in many different formats. We can print to PC or spool. We can even email the results as PC file attachments right from within the browser or the Windows environment, and also from the 52 environment as well. So that allows the deployment to be very full-featured. And with that, we're going to pass things back to Birgitta. I bet you she had a chance to sip a little water. Let's see that third tip.
So, okay, let's just start with calculating with SQL. So calculating, that can be not a big deal. So let's have a look. Let me share first my screen here. Again. Okay, let's calculate. I have here a small table with sales, and I just take my amount, and then I calculate 95%. So nothing special. So if you have a look here, these are 95%, at least if you can see, it's lower than 100%, and it's much more than half of it. So yes, it's not a big problem. But now let's have a look at the next SQL statement. Just have a look on it. And here I also calculate percent, 95%, but I use different formulas. So I generate columns A to G. So my question for you, if you have a look on this statement, do you think these columns return all the same values or not? So if they return the same values, great. But if not, why? And what happens? What do you think for your? Do you think they return everything? At the first glance, I'd say yes. But let's execute the query and have a look. Okay. Here it is. Okay, column A is great. It's the same as we have seen before. Okay, same thing in column B. Column C returns the same, except it has a few more decimal positions. Okay, that's not a big deal. We can reformat it to 2 or 4 decimal positions. But then let's have a look at column D. What happens here? Zeros. Even so, we calculate the same thing. Here we have 100%, as you can see it here. And here we have zeros again, and the last column, it's the same thing. So what's the difference, for example, between column C and D? The only difference we see here is a parenthesis. But here we also had a parenthesis. And it calculates correctly, and here it does not calculate correctly. So here we have one problem. By the way, that has nothing to do with SQL. That's because the database, or big parts of the database, are written in C. And the traditional RPG programmer, he only always calculates with numbers with decimal positions. Now we always have it. Even if we divide 2 integer values in RPG, the result gets decimal position. But that's not the general rule. The general rule means if we have 2 integer values, the result is an integer again. So if we add something or subtract something, that's not a big deal. That's the same. If we multiply something, it's not a problem. But if we divide something, then it can become a problem. So let's say here we have a parenthesis. So here we divide 95 through 100, which is 0.95, because the result is an integer again. And because we didn't round something, we get zeros here. So, and if we multiply zeros with something, the result is 0. So here we do not have a problem because we have decimal positions. So it's not a problem. Amount also have decimal position. So that's not a problem here because it has decimal position. It's interpreted as a float. And then we can multiply with integer and divide through integer, no problem. Here, the same thing. We have a parenthesis. 1 minus 5 divided through 100. So first thing what is calculated is 5 through 100. Since we do that, the result will be an integer again. And since we did not round something. So here we get a 0. 1 minus 0 is 1. 1 multiplied with something is 100%. And here with f, we have the integers at the beginning. So, and then we already have 0 here, and then we have the amount. And it calculates. Here, the first one is an integer, but we multiply it with something with decimal positions, and it's calculated correctly. So my question is, what can we do in this case? By the way, here, if we do not have decimal positions, the numbers are interpreted as integers. So what can we do? That's very easy. Let's have a look at the next example. If we do something like this, we just add a decimal position to 100. So let's see here. We have the parentheses here in D, same thing as we have seen before. It will return 0, so I execute it first. So D returns zeros. E returns 100% because it calculates first the parentheses. But if we add here a decimal position, then it's interpreted as a float, and then the result will also be a float. Same thing here. If you have a look on this, here, now it's calculated correctly. So that's one thing you have to remember, especially if you use literals or constants. If you calculate with them, or at least if you divide through them, define them with a decimal position or specify them with a decimal position, and it's calculated correctly. Otherwise, you get something like this, and the hardcore RPG programmer then will tell you, I don't use SQL, it cannot even calculate correctly. It can, it's only the rule. So in this way, we can use it, but we need to be careful. If we have, for example, in tables, like here, integer columns. So in this way, we have the order quantity and the delivery quantity. They are both defined as integer. Now let's calculate the percent of delivery. How many percent did we deliver? So formula is delivery quantity divided through order quantity multiplied with 100. So okay, we are blue-eyed. We just take the formula at it is delivery quantity divided through order quantity multiplied with 100, and here we see it. Here we have 100%, correct. But here we have 15 and 12, so we get 0. But these are 80%. Just specifying here a 0 is too late. Yeah, we still have the 0 because, yeah, these are integer values and calculated first. So what we can do, we either have to cast our order quantity correctly, or we just put our 100 at the beginning with decimal positions. And let's have a look. I have here two solutions how we can do it. So I just have the same thing. I have my delivery quantity, but this time I cast it into decimal 11.2. By the way, I also can cast it into 11.1, 0, and it will return the same result. I will show it immediately. I first execute this SQL statement, and now we see it. We have 100% for the first two positions, but here we have 80% in both cases. And here we have 0, which is correct. Here we have 60%, and yes, it's correct. So, and then we can multiply it with 100, and we get the percent. Or, because it doesn't matter in which sequence we specify our columns or values if we multiply and divide, we just can put the 100 with two decimal positions at the first position, then multiply it with delivery quantity. And now, because we have here the decimal positions, then it's interpreted as float and calculated correctly. And here it is. The final result we also can cast then and truncate the numbers, that's not a problem. But that's a rule. SQL can calculate, and SQL will calculate correctly as long as you do not use all integers. If we have two integers, the result will be an integer again. And this can be very tricky. So another thing, let me stop sharing. Here again, my slides. So here it's explained that it's an integer. Here are my examples. No, we have seen the examples. And now we have the next trick. And the next trick means, let me execute my SQL statement first. I have to share my screen, I assume. Where it is? Here. Share screen. Here it is. So let's have a look at some numbers like this. So, okay, as long as we have small numbers as 100 or even 10,000, we still can read it. But if we have numbers like this with 9 position in front of the decimal point, so it's really hard to read it. Do we have millions or 10 millions or 100 millions? So it would be nice if we have a grouping point in it. Or also if we get the minus sign. Sometimes we don't want to have the minus sign on the left side. We want to have it on the right side. Or whether we want to have here a leading zero or not. It depends. And now we have a new scalar function or an enhanced scalar function, which is the VARCHAR format function. And with the VARCHAR format functions, we are now able to format numeric values. Before release 7.3, the VARCHAR format was only used for timestamps, which was very powerful because the VARCHAR format can return a timestamp value in almost any date and time format you can imagine. And even things like the week according the ISO guidelines, etc., can be returned with the VARCHAR format. But in release 7.3, it was enhanced to convert numeric expressions. And the only thing what you have to do, that's the syntax of the VARCHAR format, you have to specify the format of the numeric value. So if we do it, a numeric representation is converted in a character representation and based on the format options, and it's always right adjusted with leading blanks or zeros are removed, but still it's right adjusted, and we can add a few additional blanks. What we need is the format for it. And for defining the format, we have a lot of elements here. So here's the syntax, VARCHAR format, then we have our numeric expression, and then we have the format string. So if you specify, for example, a 0, it means leading zeros are returned as zeros, and each 0 represents a digit. If we specify a 9, same thing, each 9 represents a digit, significant digit, but if we have leading zeros, these are replaced with blanks. The S means what happens with the negative numbers. A minus sign on the plus sign. So if we specify S, negative numbers get a leading minus sign, positive numbers get a plus sign, or we can add a dollar sign for the currency. Then we have the MI, that's also for the negative numbers. That means a minus sign is a trailing minus sign is included. For the positive numbers, a blank is included. If we specify the PR, then our negative numbers are embedded in greater lower signs, and positive numbers have a blank instead. And then we have a very interesting thing. Decimal position, we can put a comma where the group separator first. We can specify a comma where we want to have the group separator. And now we can read it. And we also have then for the decimal position, we have a decimal point. Unfortunately, for you, that's obvious. You're American, or I think most of them, you're working with group separator, comma, and decimal point. You're working with a dollar sign. But we here in Europe, especially in Germany, we have euro currency, and we use a group separator dot and the group separator comma, the decimal position comma. Okay, according to IBM, it's not a big problem because we can take this information from the message file. Let's say here from the currency symbol is taken from CPX 8416. If we specify a L, it's then the currency. If we specify the D, that's the decimal point, and the G is a group separator. Unfortunately, I only have the German, or you may have only the English language and no secondary language. How you want to take the separator from the message file? It does not work. Or if I want to print an invoice for the US and then the next one for Germany, the next one for the US again, I cannot change my system library every time. So let's have a look what we can do with this Waka format. Let me go back to my presentation here. Yes, share. Here it is. Now, the first thing I did, I take exactly the same values here, and then I take Waka format, take the number, and then I formatted it in different ways. So here, for example, with a group separator, a 0 in front of the decimal point, 2 decimal positions. By the way, it also can format your numbers. So for example, here I have only 2 decimal positions, but format it with 4 decimal positions. If you define less decimal positions here, then it just truncates it. So, and here we have the results. So we have here only with a leading 0 in front, no 0 in front. Then we have leading zeros whenever we have different numbers. Here we have the negative sign in greater lower characters. Here we have a dollar sign in front, and here we use the language separators. Oops, and I lost my connection. Sorry. Connect to database. I will reconnect. I have to reset my library list. Connect. It would not be good if it. Oh, I got it again. So just let me set my library list again. Okay. And now let's go back here to my example. So here it is. Unfortunately, I have here the English operating system and only the English language. So that's why I have here still my decimal, my group separator, comma, and not. Here I have the language currency, same thing as we have here, but here you see it for the negative values. So here we have the minus sign in front. Here, for example, we have a leading 0. We have then here, for example, a leading 0, no 0 in front of the decimal point. That's this one. Here we have all zeros. Same thing. We have a currency. Here we have the negative numbers and it is. So one trick, what you can do, or what I do, if I have to change it into German or European notation, or write an invoice in English or for the US and one for the Germans, I just put a translate around my function. I put a translate and then I just translate comma and dot to dot and comma. And here in the last one, I also change the currency symbol. So if I execute it now everything is as I expected. So here I have my euro sign, I have my group separator dot, and I have the decimal point, the decimal comma with a leading 0. My minus sign is correct wherever I expect it. Great. That's it. So in this way, you can format your numeric values in whatever kind you want to have. If you already speak about commas, numbers, numeric dates, a lot of companies still use numeric dates. SQL is very powerful in if we talk about date calculation. We have very powerful functions. Unfortunately, these functions will only work with real date and time values. So how to convert a numeric value into date? So I have seen it, or just take the date function with a numeric way and it works. No, it does not work, at least not as you expected. But SQL is very nice. It can convert a date in a valid date character representation. So that means it can convert an ISO format. That means year dash month dash day, or the European format date dot minute month dot year, or the US format month slash day slash year. That can be converted. Same thing for the date. It also can convert a numeric date. But the numeric date has nothing to do with 2020-08-06. It is the calculated number of days since January 1st in the year 1. And so we need to convert our date, our numeric date, into a character representation, and then we can convert the character representation. We can do that. Okay, I said it before, we have the year, month, day, European, ISO, European and US format. And we, but what is also a valid format is this year, month, day, hours, minutes, seconds, 14 characters or 14 numbers, and then we can convert it. This is much easier than building a string with a format and then convert it. So let's have a look at my screen, share my screen again. So here I just converted several valid character representation into a date. So here we have the date in the ISO format, in the US format. By the way, if we have a 4-digit year, it is not necessary to have a leading 0 in this case. Same thing for here. And you see here we have the difference. That's the US format, which is today, and the European format, which is a date in June. This is also a valid character representation, which means a 4-digit year, and the running or the current day in the year. So 219 is also today. And we also can convert a timestamp in either the ISO format or the ANSI format. So here's the ISO format. Here we have a dash. Then we have the separators between hours, minutes, seconds in dots and decimal positions. Or the ANSI one, here we have a colon and here we have a blank. And here's the easiest way to convert. Just take here a 14-digit year, 14-digit timestamp without separators, and we get it. Or we can also use cast. And here the last one, I checked it. So to get the number of days of the year, we can use the days function. And the number of days, calculated number of days since January 1st in the year 1 is 700,037,643. And I put it here exactly in the date. And now we get here the date. Okay, the easiest one, or how we can convert a numeric date. I have here a small table with numeric dates. And here in the first column, we have a numeric date. We can use digit substring concatenated together in a valid character representation, or as I said, the easiest way to convert a numeric date into a date is just take digit of the numeric date. So the numeric date is converted into digits, into a character representation with leading zeros, and then just concatenate 6 zeros. What does it mean? It means midnight. So we have a valid timestamp and it can be converted. The other option is we multiply our numeric date with 1 million. So we also get the decimal position, and then we use varchar to convert it in a character representation and date and get the values. So here you can see it. All 3 columns get the right date. The last one is invalid. That's why we get something wrong. So, okay, I don't want to remember everything. Yes. And I also want to catch an error. So what to do? What I did, it's very simple. I write one very, very simple stored procedure, user-defined functions. It's named convert date. It gets an 8-digit date in the format year, month, day. And then I have here my source code return. And that's what we have seen before, the conversion into a date. Okay, as far as good. And then I have here a continue handler. Continue handler traps my error for any SQL error. And if it runs into an error, I just return a date that I can trap it. So in this case, I just decided for 888 December 31st, and I created it. I already have it created. I could create it again, and then I can run it like any scalar function. So here it is. I use it, and here we see the result. So that's very easy to use then in your program. And here you see, here we have the invalidate, and then we can handle it. You also can return a null value, but dealing with a null value is always a little tricky, especially if you're working with RPG then, or embedded in RPG. And so we can convert it. Now the inverse, how we can convert it back, how we can convert a date into a time or timestamp into a real date. Oh, that's very easy, because the numeric functions such as decimal and integer and big integer are converted. And if we specify here a date in our decimal function with a length of 80, then it's returned as an integer. We also can use not varchar format to convert it back, but this is much easier. So we have the decimal, the current date, and we define it as 80, or we can also use an integer, or here the same thing for the time. So if we have here a date, so here you see we have the date today, and here we have a numeric representation, here as a decimal 8, here as a current date. Same thing we can do for the time. Here it's almost time over, so for me it's 7 p.m. And or here same thing for a timestamp. So for a timestamp, we can specify here 26. So we get the standard 6 decimal positions. We also can use a big integer. Integer won't work because we need at least 14 characters, 14 numbers. So we need big integers, take the current timestamp. And what we also can do, in SQL, the current timestamp can have up to 12 positions. If we want to have all 12 positions and not 6, we just can add here a 12. So we get all 12 positions, and then we can convert this exactly again into a decimal. Here 2612, because we want to have the 12 decimal positions, or if we truncate the decimal, so we just can use a big integer. If I execute it, here we see all 12 decimal positions here again. So here we can get it. By the way, RPG, before the last technology refresh, RPG could define a timestamp with 12 decimal positions. But with the RPG functions, we only could populate the first 3 numbers. The rest was 0. With the last technology refresh, then everything is over. So this was my tips, SQL tips. By the way, there is much more what you can do, but time is over, and Steve also want to tell you some things again, and I say thank you, and Steve, it's yours.
All righty, thanks. I really enjoyed those. We just want to wrap up with a few more things that SQL from HelpSystems offers to get more out of SQL and your SQL knowledge. So SQL comes with 2 report writers, 1 line printer style, 1 graphic. What you see is what you get. It also is multi-platform. So instead of just being IBM, we can work with a single IBM. We can work with multiple IBMs and pull data together from them. We can even retrieve data from Oracle, Microsoft SQL Server, Excel, and Access, as long as we have access to those either files or those boxes on the network. And we can bring data together from those very different platforms as well in a single result. Security can be implemented that goes above and beyond just IBM Object Authority. So additional authority can be implemented if you need it down to record level quite easily. We also have some ways to control resource use by end user limits that we can invoke, if you will, or auditing to see how resources are being used right within SQL. There's also a few things that Birgitta mentioned where she dealt with numeric field appearance and dates, and we actually have some of that functionality built into SQL, so with either UDFs or just capabilities that will maybe cater to the less technical SQL designer and give them the same power of the things that she showed you during her examples there. So I think it now goes back to the web host. Ian?
All right, great. Thanks, Stephen. We are a couple minutes over, but why don't we carve out a couple minutes past time for any questions that you may have for Stephen or Birgitta. Send in your questions on the right frame of the screen in the Q&A panel. Select to send to all panelists, and Stephen and Birgitta will answer your questions as they come in. Stephen and Birgitta, your lines are open now. This first question is, how can we find records having only numeric data in a character field?
Yeah, we can, for example, remove everything that's not a number. So for example, we have in SQL regular expressions. So we can do it if we only want to select the numbers in it. That would be one thing what we can do, or everything else would be more complex.
Okay, this next one I think is for Stephen. Is the tooling you were speaking of able to work with DBCS characters?
Yes, it can. We do support double byte character set.
All right. Next question, and again, questions bottom right frame. Select to send Q&A. Select to send to all presenters. Sorry, all panelists. All right, this one is, I think, for Birgitta. Our birth date is stored as numeric 8.0. How do we handle birth dates prior to 1/1/1940?
For SQL, it's not a problem at all. It's only the way how you display it. So normally, SQL always works with a date. So you have a numeric date. Okay, you can convert the numeric date into a real date. I have shown you how we can do that. And what we get displayed with SQL depends on the date format you use in your job. If you use a 2-digit date format, you only see the 2-digit year format. You only see the dates between 1914 and 2019. If you change the format, you will see everything is correct. SQL works differently than as RPG. That's one difference. So in RPG, it always get converted if you have a 2-digit year, and then if you have a date lower than 1940 and a 2-digit year format, then your RPG program crashes. SQL works differently. It converts a date in the so-called Scalar number, so all dates are numeric. They start with January 1st in 4713 before Christ. It's the beginning of the Julian calendar. And this number is always used. And the date format of your job, of your environment, of your program is only used to make this Scalar number visible. So you just change your date format and it works.
Okay, last chance for questions. Bottom right frame, Q&A, select to send to all panelists. There have been numerous questions about the replay, the handout, the PDF. I will say that tomorrow morning I'll send out an email to everybody who registered for this event with a link to the Common Learning Management System, where you can grab the PDF and watch the replay of the video today. And that's going to be available to anybody who registered for this for 30 days. This next question is, can we read from a CSV file and send the numeric data to a file? I saw that we could output to Excel. I'm just wondering if we can import from Excel and manipulate the formats using SQL.
We can do it. And I think I already showed it someone. There are functions, for example, there's a function which is a split in SQL, is in the systools library, so we can split an CSV into different columns and then put it together. It's not very easy, but we can do it, and we also can prepare it then with list aggregate, for example, write it back in the CSV format. That's pure SQL. We can do it. Sometimes ago I wrote even an UDF to read from any CSV file, but it was from my former company where I used it. And yeah, it's possible in either way. Not very easy, but it can be done.
Okay, and here is the final question. Again, I think this is for Birgitta. In your calculation examples, the results, especially for the divisions, are formatted with a bunch of decimal positions. How can we format the results to a specific number of positions?
So that's we can use the cast function then. After we calculated the expression, just put cast around one decimal. So cast is for all data types. The decimal is only for decimal positions. And then you can format it for the number of decimal positions you want. By the way, it is then truncated. There are also rounding functions in SQL that you can use if you say, okay, I have 26 decimal positions. I only want to have the first 3 decimal positions, but I want them to be rounded on 3 positions. Then I could nest the round function in it and round it to 3 decimal positions and then cast the result with 3 decimal positions.
Okay, great. We are 10 minutes after, so why don't we go ahead and end at this point. Thank you for attending, everybody, today. Brigitte and Stephen, thank you for a great presentation.
You're welcome.
Well, thanks for having us.
Yes.
Everybody have a good day.
For me too. Was fun to speak. Okay, thanks. Bye.
Have a great rest of your week, everybody.